So we left off Thursday with these three problems, and I asked you to try these out and see if you can come up with. I said that the first one wasn't too bad, and then the next two were kind of tough. Now, I don't know for sure if I put these X's on there or not, but this is what I would do if it were me solving these problems, trying to figure out exactly how to rewrite this. Rewriting them is 99% of the battle right this second. Eventually, we will learn how to solve these and how to use these as we move forward. Right now, we don't know how to solve a log. So since we don't know how to solve a log, we have to try to write it in exponential form, which is going to make more sense. So what you do is you're going to drop the log part, and then you're going to switch the number in the x. So this is basically saying 4 to the x power is equal to 64. Remember, this is switching from log form to exponential form and vice versa. You have to be able to do both of those. So we have now switched from log form to exponential form, and now we ask the question 4 to what power equals 64. Now we might not know that off the top of our head, but it at least puts us in a part where we're a little bit more comfortable, right? So it at least puts us in an idea where we can find x by guessing and checking a little easier than we would if we had to solve this thing using logs. So what you're going to end up doing is finding out that x to the third is the same thing as 64. I'm sorry, 4 to the third power is the same thing as 64. So you would find x equals 3. The next one is a little bit more challenging, but you should still be able to change this into exponential form because that was the toughest part of this entire thing. Now, this might be kind of tough because a lot of people don't really think about 0.2 as an easy number to change 5 into, but if you end up changing this instead of 0.2 to 1/5, so 5 to the x power equals 1/5, that might be a little bit easier to look at. So I want 5 to turn into 1/5. How do I make something go from the top to the denominator? Using a negative. So this is saying that if x equals -1, so 5 to the -1 power, 5 to the -1 power is the exact same thing as 5 to the 1, or 1/5. And then the last one, again, we switch the two, switch their spots, so you end up with 1/5 to the x power is equal to 1/25. Now, obviously, we're going from fraction to whole number, right? We're going from a fraction to a whole number, which if we're going from a fraction to a whole number, we're still going to need the negative. So this is basically saying 1/5 to the negative something is going to be equal to 1/25. If I say negative something, that's going to make this 5. So 5, basically, I'm saying 5 to the what power equals 1/25, and that should be the third power. So this is telling you that x is equal to -3. So if you type in your calculator 1/5 to the -3rd power, you're going to get 1/25. So the tough part about this, yes, might be switching it from log form to exponential form. That might be kind of tricky because you're not used to it yet. But the tough part about this is using negative exponents. And negative exponents are things that we learned a while ago. We actually learned those in chapter 5. So that's old stuff. All right. So as of right now, the tough stuff isn't the new stuff that deals with logs. The tough things are dealing with the negative exponents and the negative values. And those are kind of tricky. Questions that you can think of right now before we start new stuff? Okay, now when I say new stuff, this is still section 6.3, so it's not really new. It just has to do with solving and finding inverses. Now we did, I'm just making sure because my other classes ended in different spots. We did talk about the common log, which is log-based f, right? And we talked about the natural log, which is log-based e, right? Okay, so we talked about those. We also wrote down the form that said log-based b of 1 equals 0, right? Did I have you guys try to tell me what log base b of b is, like this? And log base b of 1 equals 0. We went through these two formulas. Okay. So now really the only thing left is to try and figure out how to solve these things. Right? Now, this is the equivalent of if I ask you to solve something using multiplication and division. If I ask you to solve the equation 5x equals 10, how, like, first off, you would describe this as multiplication is happening to the x, right? If I said what's happening to the x, you would say there's multiplication happening to the x. And then I would say, how do you undo that? And you would all respond with what? You would divide, right? If multiplication is happening, you would divide, right? If division is happening, so like x divided by 5 equals 10, if division is happening, you would multiply. If subtraction is happening, you would add. If addition is happening, you would subtract. So the way that you are undoing things is by using the inverse operation, correct? So instead of having multiplication, you would use division. Instead of using addition, you would use subtraction. The same exact thing is true when you're dealing with exponents and logs. Exponents undo logs, and logs undo exponents, okay? So if I'm asking you to undo something that's happening to an x, you're going to use a log. So for instance, if I see something that looks like this, 5 to the x power equals whatever. This is, so what's happening? What's happening is that there is an exponent. What you need to do is you need to undo the exponent. And the way that you undo the exponent is by using logs. Okay. Now I'm not actually going through how to solve this at this point. I'm just trying to draw your attention as to what you're looking at. You see that there is an x in the power, right? There's a variable in the power. That means that there is an exponential equation happening. We need to undo that, and in order to undo that, you need to use a log. Now you can do the same exact thing if you look at a question like this, where it says like log base 5 of x equals something. Doesn't matter what it is. Again, what's happening is that there is a log function. To undo that, you need to use exponents. And actually, I'm going to put exponential. Just a little bit different. Okay, so again, the first step is identifying what's happening. The next step is identifying how to undo that thing. But if you can identify right away, okay, I see there's an exponent there. In order to undo an exponent, you use a log. In order to undo a log, you use an exponent. The same exact way that has been ingrained in you for the last several years. In order to undo multiplication, you divide. In order to undo addition, you subtract. Same exact thing. Okay? Make sense so far? Okay? Okay, so the next part is the inverse. I don't know if you want to call them, we'll call them properties. So inverse properties. And here I'm going to put undo logs and exponents. So using inverse properties allows you to undo logs or exponents. Okay. So the first thing is we need to know the idea, or we have to understand that these two things are inverses. So y equals log base b of x, and y equals b to the x power. These are inverses. So those two things are inverse functions. Okay. So y equals log base b of x and y equals b to the x power are inverses of each other. All right. So since those are inverses of each other, that means they undo each other. This whole thing, I could go through like how to like the composition of these functions, but most of you don't care. These have created the two inverse properties that we're going to be using constantly. And these two inverse properties are going to be probably two of the most important things that you deal with in this chapter. Like not even section, the whole chapter. All right. My first property is log base b of b to the x power. Okay, I'll give you a second to look at that and see what it said. So remember on Thursday, I had said that like the first b is a subscript. The next thing is in line with it, and then you're allowed to have exponents on top of it as well. So this is saying the way that I would read this out loud in words, log base b of b to the x power. Okay, log base b of b to the x. Since these things undo each other, notice how I have an x in the exponent, right? I have an x in the exponent, and I have a log. I have an exponential and a log working against each other, which means that this whole thing right here is going to cancel. That whole thing right there is going to go away, and it's going to become just x. So log base b of b to the x power is equal to x. Okay, those things cancel. Now that should be something that you can kind of see happen. That's something that you can kind of see, right? The next inverse property is this one. If I have b raised to the log base b of x, you can see now we have b being raised to a power, and we have a log in the equation. So I have a power and I have a log, which by definition, these undo each other because they're inverse properties. So log and exponents undo each other, which means that they go away. So these two things right here will cancel, and it will become x. So this introduces us the idea of how to be able to solve a log equation. So this gives us the idea of how we can actually start to solve. All right. And starting to solve is very, very important because you need to be able to get x out of the exponent. And right now, we don't know how to do that. We also don't know how to solve an equation that has a log in it, because most of the time what people are going to try to do is something with division. That doesn't automatically work. All right. Any questions right now that you can see, or what you're looking at, or what ideas that you guys have come up with so far? These two properties, if it were me, I would make sure that I star those or do something with them, because they're going to be properties that keep coming back over and over and over and over. Right? So let's simplify. Let's try a couple of these things. Let's see what they ask us. So let's simplify 10 log to the fourth power equals 4. And then log base 5 of 25. Actually, hang on. Let's erase that 4, because that actually is. So let's simplify. Right? A couple things to note and a couple things to think about. Your big job when dealing with exponents and logs is going to be to try to get the bases to be the same. And there are two spots in here. When I see base, there's two spots that I'm looking at. Okay? Because if you're thinking about it, and I'm talking for each question, there's two spots for each question where you think about bases. If we look at this one, this one's a little bit more clear cut. This thing right here is a base. Log base b of, or log base 5, right? So that 5 is a base. When I say logs, I actually say the word base. I say log base whatever, right? And then the second thing is I see 25 to the x power. Anytime you have something raised to a power, that thing is a base, right? So anytime that we see a base or we hear the word base, we're actually thinking in two spots. Log base 5 and 25 to some power. Those things are both bases. Your objective when simplifying is to get the bases the same. So I want to try to get the bases to be the same exact number. Because if the bases are the same, I can then start to cancel things. If the bases aren't the same, I can't get things to cancel. Okay? So if the bases are the same, I can start to cancel. If they're not the same, I can't. Okay? So let's work our way through so that we can see kind of what's happening. This one right here is tricky. One of the bases is 10. So this is a base right here. And then one of the bases, I don't know if this is clear the way that I wrote it. That 4 is the big number, not the base. What is the base right here? It is 10. Remember the common log? Remember what I said with the common log on Thursday? I said the common log means that it is log base 10. So even though it doesn't actually show you what the base is, we know that that base is 10. We know that. All right, so we should be able to see right away that the base is 10. So when I solve this, I end up getting 10 to the log. I'm going to write the 10 here, even though it's not necessary that I write it. Log base 10 of 4. That's what that thing looks like. And remember, based on the last thing that we just did, the inverse properties, I now have 10 raised to a power, and I'm taking log base 10. So 10 to a power log 10. I now have two things that are undoing each other. I have an exponent and I have a base. They're all log. Well, exponent and log. Both of them have bases of 10, which means that this thing right here is going to go away completely, and it is going to equal 4. Okay? So hopefully that makes sense. Right? The next one is a little bit trickier, and the reason that it's a little bit trickier is because you notice that these two bases are not the same. In the example on the left, the bases were the same, right? There is a base of 10 being the exponent thing, and then there was a base of 10 in the logs. They were the same. This one, they're not the same. Is it possible for me to rewrite 25 as 5 to the something? It is, right? I can write 25 as a base of 5, right? So what I would do is I would rewrite this as log base 5, and then what I'm going to do is I'm going to change that 25 to 5 squared. And other than that, I have changed absolutely nothing about my problem other than the way that 25 looked, right? The only thing that I've changed at all is the way that 25 looked. 25 looked like 25 before, now it looks like 5 squared. Now remember, when you have a power to a power, you multiply. So this is the same exact thing as saying 2 to the or 2 times x, right? So I'm going to now rewrite this as log base 5 of 5 to the 2x power. And now if you look at my bases, the bases are the exact same. My job was to get them to be the same, and I did. And now the beautiful thing is, these two things undo each other. I have 5 to a power, which means exponential, and I have log base 5, which means log. Logs and exponents undo each other, which means that they go away, so this thing simplifies down to 2x. Okay? I was going to give you guys big ideas today, but I'm not going to do big ideas, I don't think. I think what I'm going to do is I'm just going to give you some homework questions to kind of work on, and that way we can start tomorrow off with some question and answers, because I think there is still some confusion and still some issues that go along with logs and stuff. So look on Google Classroom tonight, and I'll have a few questions on there from your book that I want you to try. And then you guys can start out with that tomorrow, asking questions on things that do or don't make sense. Okay? Any questions you guys can think of at this very moment? All right, beautiful. So if you have any questions, make sure you let me know.